In this video, I'd like to address some questions that we received from pest control operators regarding the portable heat injector system used for the heat treatment of eradication of bed bugs.
How can the heat injector recirculate the air when other propane systems cannot?
Well, the patented technology used in the heat injector creates a unique method that allows fresh air to always be used for the burning process. This allows the heat injector to always have a clean burn through entire heating range. So it allows the air to actually be heated, pushed into the house, brought back, recirculated, and continue to be recycled until the house gets up to temperature. This technology is something that we use in the HVAC market. We used it in the industrial market, something that was patented in 2008 and it was released to the market in 2010. And now we have it in industrial and commercial buildings, heating some of the largest automobile plants and carpet mills in the country.
Now you say you recirculate air. Do you use fans?
No, we don't have to use fans with the heat injector. It uses an industrial blower, and it actually moves air through flexible duct to remote locations in the house. And then the air, after it's transitioned, after it's deposited its heat, it actually recirculates through the house back to the air intake. The air intake then reheats it and resends the heated air back to remote locations in the house.
How much duct would you have to bring to a job, or how much can you use?
Well, there's no limit to the amount of duct work that it can run. It's designed to heat any size home, and basically the duct work is used to transfer the heated air, the BTU energy, into the remote locations, and whatever it would take for a typical house is the amount of ductwork that it can actually use. And in our distribution system, we have it so that we wire the ductwork, and we go through a distribution box where you put the one port in, and you may have seen it where you have 4 ports on the discharge. So we basically allow multiple ports to disperse heat into all different spots in the house, and then after those spots are heated, the excess heat actually gets transferred through the structure back to the air intake until finally the house is totally heated.
Now, how can you move all this air through all that ductwork? The typical tube heater, you max out at 25 feet.
We thought about that, and I created a concept called HP Boost, and basically we do 2 things. One of them, we use an industrial blower instead of a tube axial fan, which is just like a fan that would move air in your house. And it's designed to actually move air under a load of a ductwork. The HP Boost actually senses the load of the ductwork, and when it starts to increase, it actually shifts the speed of the blower so that it actually moves more air under load.
Now, the heat injector is more expensive than the typical propane system. How can the pest control operator justify that cost?
You know, I guess it's broken into 2 pieces. One of them is equipment costs. It is cheaper to buy it, just like a car that gets 15 miles a gallon is cheaper to buy than one that gets 40 miles a gallon. But the heat injector uses a lot less fuel. The typical propane system has to pull all the air from the outside, heat it, and then it pushes it into the house. The heat injector recirculates the air. So on a cold day, the typical propane system would actually have to pull air from the outside, heat it up to the normal ambient temperature of the house, and then heat the air up further to actually elevate it to the temperatures that would be used for eradicating bed bugs. We start at 70 and then go up from there. So our air intake is continually pulling higher and higher and higher inlet temperatures, and so therefore we have to use a lot less fuel. Probably less than half the fuel of the typical system, the typical propane system.
Now, how does the heat injector compare to the typical electric system with an external generator?
Well, the generator has to be running during every hour of operation. The generator consists of a motor. The motor then spins a generator, then it goes through a distribution system. The distribution system then has to be used with a number of heaters, and then there are additional fans. So all of that is drawing upon the generator in order to produce the system. And our system uses, again, a completely different process, and it uses half the fuel of the typical electric system, does twice the work of a 4-unit system, does more work than 8-unit system, so it does more heat than an 8-unit system. So using half the fuel, doing twice the work is a pretty good thing.
Now, what would you say the largest home the heat injector can treat?
Well, that would be limited based upon a continuous airflow. The structure needs to have a continuous airflow from where we push the air into the house and where it gets back to the air intake. This typical, you'd be able to cover 2,500 square foot at one time. If the house is bigger than that, then you'd actually have to do it in stages, where you'd actually let the excess heat from the first area start to heat the second area, and then you would just have to move the ductwork from the first area to the second area. Some electric systems have to do the same thing. It's just that it's a whole lot easier to move flexible duct around than it is heaters and fans and that sort of thing. So to answer your question, it can actually be any size home can be treated with the heat injector system.
Now, how is your heat treatment process different than other heating equipment?
Well, you know, one of the things that we can do in our system is we can actually, a part of the process is that we heat the environment, and then we're able to pressurize the environment to push air through any cracks in the structure. An electric system wouldn't be able to pressurize the system because all their fans are actually located in the structure and they're trying to move the air through the structure. So that's how we differ from the typical electric system. On the propane system, the fact that we recirculate the air and the fact that we have controlled discharge temperatures. You know, the propane system puts out heat immediately, but one of the things that we have is we have automatic control on our temperature. So therefore, when you set it at 140 degrees, it continually monitors the airflow. If you slow the airspeed down or increase the airspeed, it's always going to produce heat at 140 degrees. And the one thing about heat is you can't stack heat up. Heat always dissipates. If you discharge it at 140, nothing in the house is going to be higher than 140. The typical propane system puts heat into the house, possibly significantly higher, and then it's based upon the assumption that you mix that air up. The objects in the house will become the temperature of the ambient air, so you need to make sure that the ambient air temperature is controlled. And that's what we do. Immediate heat at controlled discharge temperatures.
Awesome. Well, thank you again for meeting with me today. If you want to go ahead and give the viewers here your website.
Well, our website is heatinjector.com. You can also call us. Our phone number's on our website. You can hit the contact button on the website to connect with us. We'd be happy to answer any questions that you might have. It is a new paradigm in the heat treating equipment, so we want to make sure that we answer all of your questions. It's a proven technology. We use it in automatic operations throughout the country, in the HVAC and industrial markets, so we really feel comfortable and confident that this will become a significant heat treating piece of equipment in the pest control community. And we thank you for your attention to this video.